Hi guys, so I just want to share with you some of the knowledge, insights, and experience that I've got after exploring some of the advanced topics of TypeScript. So first of all, this is not some sort of tutorial or educational, video that will explain you these advanced topics. You must be familiar with them, and let's get down to the business. So I needed to create a function, a custom function that will merge two objects in the TypeScript way. And the key thing was that I had to write some return type that will that will be actually the intersection of two types of two objects to be merged together. So here is an example how this function works. It just takes two objects and combines them. So the end result will look something like this. Is brought false, logs true, props, logs 1, 111, 22, data 1, 2, 3. So this is actually how the end result will look like, what this function returns. So if I hover over this variable, I see the typings, and it's actually intersection of two types of these two variables. This is exactly what I need. So if I type and try to access all of the variables, I get it all here. It all happened due to the typing that I've made. Actually, not. I haven't made it. I just found it on Stack Overflow, and when I was googling this issue. So my challenge was how to return a merge type of two objects. I really had no idea how to do that. And then I found out that all I need to do is to have these two types combined together. And I won't be going much around this subtype, how it works. So I will just share with you some of the confusion that I've got with this type, because so what is that type? It actually a type that consists of two conditional types, where one of them is nested. So here's like first conditional type, which is nested into this conditional type. And my first idea was like, wait, this should always return to true, so why can't we just write down something like this? And actually it won't work, because it won't create an intersection of two types. It will be just still the union of two types, or of two objects, I mean. So this is not the way how it works. And in order to understand how it works, let's break it down. So first of all, you have to understand what a conditional type is. Second of all, you have to know what infer means. And third of all, you have to know what is naked and not naked type. So here we have an naked type, a naked generic type U, and conditional type treat these naked types very interestingly when you work with unions. So that when you use unions with this type, when you pass a union to this generic type, it will take each part of that union and use it with this conditional. So here, let me give you some example. For example, we sort of let's for example say that we are trying to merge. So there is some variable merged, which will have a type merge, which will have no, let's do it in another way. So let's say that I pass the following object, is prod false, and second object logs true. So say I pass this array of objects to this merge type, and due to this syntaxes, it will create a union of these two types. So eventually this will look like not a number, but an intersection of isprod. Actually, it's going to be boolean and logs to true. So this is how just you have to know how this accessing array elements works in the TypeScript. So I will provide the link in the description section, so you will get how it works. So eventually this type will get a union type of all of the objects that will be passed to this array. And as I said before, TypeScript treats union specifically when you have an naked generic type. So and all it does, it takes each union part and uses it in this conditional. So in our case, we will have it like in the following way. So we will have it like isProd boolean if it extends to any, then we are going ku void never, oh my god, extends. So I just can copy and paste that. We will have this expression here. Can I just like ts ignore this stuff? And so it took the first part of this union type and applied it to the whole union to intersection type. And the same will happen again. The same will happen with the second part of this object, of this union, which is logs. It should be boolean, not the actual value. And so this is eventually how this will look like. So as this is a naked type that is being used in the conditional type, and as we use a union type, as we pass union type to this type, it will treat each element of this type separately to this whole function, to this whole union, to this whole union to intersection type. So this is actually what we will have. So our first thing, first expression and second expression, and it will be simplified. For example, let's say like the first stage. So at the first stage we have in this thing, actually we won't have it here. At the second stage we will actually simplify it now. So we already know that this prod extends to any will equal to true. Thus we will have, at the second stage we'll have this, but instead of u we will have isProd boolean, and we will have the rest of this type, rest of this conditional type extends, oh my god, k infer I void, oh god, void, and if that is so, then it would turn I or never. And union type, just the same, but it has logs boolean. So here's what we got. And again, you have to know how infer works first of all in order to understand how it works. And at the third stage, it will just like check if this function type is a subtype of this function type, which will return also to true. Then we will return I, and I will be equal for the first case, I will be equal to isProd to boolean, and for the second stage we will have for the second element we will have logs of boolean. But since we, this is like the second thing that you have to know. Since we infer value in the covariant position, which is actually another thing you have to understand, then this relationship between this type will be turned from the union to intersection, so that it will be end logs boolean. So this is how the end result will look like. And let's now, so this is actually exactly what we've got. This is how it works. But let's see why a simplified version of this type is not working. So this is how it works with the real function, and let's try to see why it won't work with the simplified version of this function. So it's pretty easy. It won't work just because we won't be dealing with the intersection, and the intersection just happened because first of all we divided all union types into separate chunks, and intersection happened due to the inference, because when you infer a value, when you infer a type from a covariant position, it will turn union into intersection. That's just how TypeScript works. And so eventually, if we use this type, then again, let's go back how I wrote it before. It will have like is prod false or logs true. I mean, like, it should be all boolean. And as we got rid of the conditional type, we won't be, as we got rid of conditional type and naked type, we won't be able to treat each element of this union type separately with this whole function. It will be taken as it is and inserted into this function. So eventually all we will have here is something like k equal of type is prod boolean or logs boolean extends k infer I void then return I or never. So this will return to true, and I will be equal to this value. So the return value of the return type will be just a union of these two types, is prod boolean or logs boolean. So how did we get it here? So we just these wait a minute. This union type will extend the function parameter of this type, and eventually this type will be returned. So this is the final type that we are going to have, and as it's not using intersection, it won't be just possible to use it as a merge type. So that's why we cannot use this simplified version of this function, just because we're getting rid of some of the features, like being able to treat different parts of union type separately, and thus being able to create an intersection between all of them due to the inference. So I know it's kind of messy to understand, but I think it really helped you to, maybe to take a look at this whole situation, at this whole, union to intersection type at some other angle. So if that is so please write it down in the comment section below. If it's not, still, well, I hope it is not like not useful. I really want to know that that this is going to be useful. So thank you.